Going to start looking at some applications of vectors. First, we have to take a look at what are called bearing of objects and at what's called the direction angle. We always found before we talked about the magnitude of a vector had direction and magnitude. A vector had direction and magnitude. It had a certain miles per hour or force or something magnitude of it. And then there was a direction angle that went from 0 this way. Okay? And that's what the direction angle. This is called the direction angle. So if a vector had a magnitude of v, let's say that it had a magnitude of 150 miles per hour, and the direction angle was, I don't know, let's say 125 degrees. So what that is, that's a vector that's starting from here, and it's going 125 degrees this way. And it has a magnitude of 150 miles per hour. What we want to do is break that into component form. And what that is that's how much of the vector is going in this direction, what's this length, and what's this length going up in this direction, the y value. And remember that component form, we used a little thing that looked like that. And all it really is just the magnitude of the vector v times the cosine of the direction angle and the magnitude of the vector v times the sine of the direction angle. And that's really all we're going to do to find that. So to find the component form of this vector, all I do is just go, put that funny little arrow thing like that, and I'm just going to go 150 times the cosine of 125 and 150 times the sine of 125 degrees. And then you just take your calculator and my calculator just died. All right, well, I'll get a different calculator. So I take the calculator, here's this one, we're in degrees, so I'm just going to take 150 times the cosine of 125, and I get negative 86.036. And notice that makes sense because this component is negative. We're going that way. And then you do 150 times the sine of 125, and we get 122.873. And there's the component form of that vector. And what that is this, it's broken into two parts. This part horizontal is negative 86.036. This part vertical is 122.873. If you did the Pythagorean theorem on this squared plus this squared, it's going to equal 150. You don't have to do that, but that's just a little thing to know. Okay? So that's really not that difficult, but that's kind of the basis of what we're going to be doing to solve the kind of application problems we're going to be doing. Now, when you talk about navigation problems, okay, navigation, they throw a curveball in there in the fact that for direction angles, we start from 0 and we go this way around the circle to 360. In navigation, 0 is north, and the angles go this way around. And so that's called the bearing of the ship or of the plane or whatever it happens to be. The bearing angle is a different angle than the direction angle. And you just have to, there's a relationship between them. I'm not going to get into where this comes from, but to find it, it's just that the bearing angle plus the direction angle equals 450. And so whichever one you're trying to find, if I know the bearing and I'm trying to find the direction angle, all I'm going to do is subtract it and say the direction angle equals 450 minus the bearing. Or you could do it the other way, the bearing equals 450 minus the direction angle. And so that's kind of the key that we're going to be using when they give you bearing. So let's say that we have a plane flying uh, 285 miles per hour on a bearing of 189 degrees. Find the component form of the airplane. So first of all, because it says bearing, we need to find the direction angle. And so my direction angle is going to equal 450 minus the bearing, which if you do that, we get 450 minus 189. Comes out to 261 degrees. That's my direction angle. So if you went 189 degrees around here, okay, that's 180 plus 9 degrees more. Think about what that would be going this way. 180 plus 9 degrees less than 90, 81. That's 261 degrees. And that's really where that came from. It's just that this formula makes it a little bit easier. So now all I do to find component form for the airplane is all I do is I'm going to go the magnitude of it, 285, times the cosine of its direction angle, 285 times the sine of 261. Take your calculator, clear that out of there, and I'm just going to put that in there. 285 times the cosine of 261, and we get negative 44.584, and 285 times the sine of 261 minus 281.491. And there's the answer to that in component form. And that's those are the two kinds of problems you're going to have on this assignment today. Just remember that bearing is from here this way, direction angle is from here this way. And in order to use this for direction angle, for finding component form, this has to be the direction angle, not the bearing. Okay? All right.